We'll be looking at finding segment lengths in circles. We have a theorem that said that if we have two chords that intersect in the interior of a circle, then the product of the length of the segments of one chord is equal to the product of the length of the segments of the other chords. So chord AB can be divided up into AE and EB. Chord DC can be divided up into DE and EC. So the two parts of AB multiplied together must equal the two parts of CD multiplied together. So in this case, we want to find the length of ML and the length of JK. So what I'm going to have to do is multiply the two parts. So I'm going to have NK and NJ multiplied together and NL and NM multiplied together. So when I plug that in, that is the two parts of KJ, x times x plus 4, is equal to the product of the two parts of ML, x plus 1 times x plus 2. So we need to use our distributive property on the left and FOIL on the right, and we get x squared plus 4x is equal to x squared plus 3x plus 2. Now we know we can subtract away the x squares. We get 4x equals 3x plus 2. Now subtract 3x and we find that x is 2. But that doesn't answer our question, so we need to plug in. Remember that ML is equal to k plus 2 added to, x plus 2 added to x plus 1. So we're not going to multiply them now, we're adding them to get our total length. We plug in our numbers and find out that ML is 7. In order to get KJ or JK, we add its two parts, x and x plus 4. We know that x is 2, so that comes out to be 8. So here's a little problem for you to try. We come out with x equal 8. Now how did I get that? I said the two parts of one, 3 times x, is equal to the product of the parts of the other one, 4 times 6. So 3x is 24. That gives me an x of 8. Now, tangents and secants. A secant segment is a segment that contains a chord of a circle and has exactly one point on the outside. So instead of a secant line, what we have is a secant segment, because it is just a line segment, but it is a secant to the circle since it goes through the circle, hitting it at 2 points. In my secant segment, I've got an external segment and an internal segment, an external part, an internal part. My tangent segment is just a line segment that is a tangent to a circle. Segments of secants. If two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the length of the other secant segment and its external. Now notice what I'm doing here. I'm doing EA times the entire thing, EB. Not the two sections as we did when it was chords, but the entire length of EB times the external part. So external times whole on both of those. So to get this one, what is the value of x? Well, I need the external part 3 times the whole TR, which is 3 plus x, and I need the whole 4 external part times the entire part, which is 5 plus 4, or 9. So I have 4 times 9 is equal to 3 times x plus 3. So 36 is 3x plus 9. So x is equal to 9 when I solve that problem. So remember what we have to do, the external times the entire segment. Correct answer in this case is D. So in this one, the same thing. I need my external part times the entire segment. So for this line segment down at the bottom, or this secant segment down at the bottom, I need x plus 1 multiplied times the two of them added together. And at top, I've got 3 times the two of them added together, the two parts added together. Doing a little simplifying gives me x plus 1 times 2x and 3 times x plus 5. So when I distribute that, I get 2x squared plus 2x and 3x plus 15. Since I have only one x squared, I can't get rid of it. I need to set it equal to 0. In this case, remember we have several options for doing this. We can use the quadratic formula. We could try completing the square. We could try factoring this. We could set it equal to y, put it into the calculator and find our zeros. I'm going to use the quadratic formula in this case just to give you a little more practice doing it. Remember the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So when I plug in my numbers and work it out, I see that I've got 1 plus 11 over 4. Now why didn't I use the minus 11? Because that would give me a negative x, and that would not work. So x comes out to be 3 in this case. So you got to remember that quadratic formula. So this is going to be practicing some of our algebra skills that we did in Algebra 1. So find the values of x here. This is for you to try. It comes out that x is 13. Now how did I get that? Remember the external part, 5, times the whole thing, x plus 5, has to equal the external part of the other one, 6, times the whole thing, which is 9 plus 6. So 5x plus 25 is 90. Solving for x, I see that x is 13. Segments of secants and tangents. Now, if a secant segment and a tangent segment share an endpoint, then we know that the secant segment, how it works, is the external part times the whole thing, but how does that tangent work? Well, it actually comes out to be the square of that tangent segment. So in this one, I have a tangent segment of 16, and I have a secant segment that's made up of x and 8. So my 16 square is going to have to be x times x plus 8. So that gives me 256 is equal to x squared plus 8x. Since I've got an x squared I can't get rid of, I need to make it equal to 0. Once again, we could factor, we could use the quadratic formula, we could set it equal to y in our calculator. We have several options. If I use the quadratic formula, I come out that x is approximately 12.5. Like I say, you could get that several other ways. Find the value of x in this case. Well, I have a tangent, so that x squared is going to have to be equal to 1 times 1 plus 3. So x squared is 4. If I take the square root, x is 2. How about this one? My answer comes out to be 24 over 5. Now, how did we get that? We said 7 squared is equal to 5 times 5 plus x, which gave me 49 equals 25 plus 5x, so 24 was equal to 5x, so I divided by 5. Here's a third one. Once again, you should be able to work this. It comes out to be 8. How did we get 8? We did 12 squared is equal to x times x plus 10. So 144 is equal to x squared plus 10x, set it equal to 0, and then either use the quadratic formula, try factoring it, or using your calculator. So here's a little guided practice for you. How are we going to do this one? My answer comes out to be approximately 9.6. Where did that come from? What I did was say 15 squared is equal to x times x plus 14. So 15 squared is 225 is equal to x squared plus 14x. So 0 is equal to x squared plus 14x. minus 225. If I solve that, I can use the quadratic formula, or I could, remember, use my calculator, and I get approximately 9.6. In this one, how do we do it? Now remember, this goes back to where this the two chords, so I get 8, and how did I get that? I simply said 18 times x has to equal 9 times 16. 9 times 16 is 144, so 18x is 144, and dividing by 18 gives me x is equal to 8. In this one, let's think about it. What we've got is two secant segments, and for my secant segments, remember, the x must be multiplied times the whole thing, x plus 29. Well, I'm writing that right where the answer is going to show up. So let me erase that and move it down a little bit. Your answer that you will get is 16 when you say x times x plus 29 is equal to 18 times 18 plus 22. So x squared plus 29x is going to be 18 plus 22 gives me 40, and multiply that times 18 gives me 720. So x squared plus 29x minus 720 is equal to 0, and using quadratic formula I get 16. Now, real world application here. We're talking about moons of Saturn. We have 3 of them. We've got Telesto, Calypso, and Tethys. And we sent a satellite, the Cassini, up. What we're going to do is find the distance from Cassini to Tethys by taking advantage. We know that we've got a tangent here. We know the outside part, so we're looking for the inside part. So DC is equal to DB, or DC times DB is equal to AD squared. Plug in my numbers and we'll solve it